So in this lecture I will discuss about switch bouncing. So switch bouncing: when a mechanical switch is closed or open, the switch contact will bounce, causing noise in the switch output. For example, this is a switch and 5V is connected to the switch. Initially it is open. When it is closed, that is directly connected to the ground. Okay. So when it is connected to the position B or the point B, it is normally there exists a bounce back, because the switch is normally made up of a mechanical thing. So if for a mechanical switch, bouncing will be there. Okay. So when a mechanical switch is closed or open, the switch contact will bounce, causing noise in the switch output. That is, bounce means this type of pulses. This is connected to this point B, but it is bouncing back. So actually, when it is connected to B, a high voltage is connected to the point B, like that. So a 1 will be there, but the problem it is not connected. It is not keep in touch with B. It is actually vibrating or oscillating, or it is bouncing at the point B. So there is a 1 and 0 combination can keep. This is bouncing. Okay. So the switch contact will bounce, causing noise in the switch output. The contact may bounce for several milliseconds before it settles down to the final position. Okay. The contact may bounce for several milliseconds before it settles down to the final position. So when it is connected to B, this 5V is connected to ground. That means we get a 0 voltage. Okay. That means it should go to 0, but instead of going to 0, for a small time duration, a 1 will be coming. A sudden 1 pulse coming, then it is 0 again. A sudden 1 pulse, high pulse coming, again 0, like that. That means this pulse is due to the bouncing of the switch at the point B. Okay. So this kind of bouncing creates noise in the circuit. Okay. Why? Because it is not actually connected to B. It is connected to B, but due to this mechanical thing, it is actually tuning now. So it is coming back and forth. So a bouncing will be there. That we should eliminate. Oh, okay. So mechanical switch, we must debounce the switch. Debouncing means removing the transients in the switch output. This is actually called the transients. Okay. These are steady states. This is a steady state, means if it is 1, it will be continuing in 1. That is a steady state. If 0 is a stable state, it will be continuing in 0 state. But here a transient came. That means a pulse is coming. That we should remove. For that we need to debounce the switch. Okay, debouncing circuit removes the series of pulses that result from the contact bounce. Okay, and produce a single smooth transition from 0 to 1 or 1 to 0. See, the bouncing circuit removes a series of pulses, the debouncing circuit. So we need to implement debouncing circuit to eliminate this kind of transients. Okay, so that we will get a smooth transition from 0 to 1 or 1 to 0, like this here, 1 to 0. So we need a smooth transition. We don't expect this kind of bounces or this kind of transients, so we can eliminate with the help of debouncing circuit. So figure below shows the debouncing circuit that consists of single pole dual throw switch, SPDT switch with SR latch. Okay, so listen and look at here. VDD is connected. It is 1, 2. Okay, this is a switch 1. Okay, now switch position 1. Switch is in, now the switch is in position 1. Here the position 1. Switch is in position 1. So what will happen? That VDD is directly connected to ground. Why? Because switch is connected to here. So this supply getting a low resistance path, so it is directly go to the ground. So at that time, this latch R gate, okay, this R, it is connected to high voltage. VDD is nothing but DC supply, high voltage. So this R is connected to high. So high will be here, that is 1 will be here, here what it is here, 0 will be here, that is S is 0, R is 1. When S is 0, Q output is 1. Why? Because NAND gate 1 input is 0, output will be 1 only. Okay. So Q is 1, Q bar is 0. That's why it is written like this. Now we move the switch to position 2. So in normal case there is just a bouncing. That bouncing should be eliminated. For that purpose we implemented this debouncing circuit. So switch is in position 2. So what will happen? Immediately S is connected to 1. Why? Because a high supply voltage is connected to here, and this is in position 2 means this supply is connected to ground, so here 0. R is 0, S is 1. When R 0, Q bar is 1, Q is 0. When R 0, no, R 0. So definitely Q bar will be 1. 1 input of AND gate is 0, output will be 1. Okay. So here S is 1 and R is 0. So Q bar is 1. So Q is 0. So this is the condition. Okay. When the switch is thrown from 1 to 2, after switch make initial contact with 2, it bounces several times. Okay. It bounces several times, but it won't go to the position 1. The output of the latch is unaffected by the bounce because output latch always remains Q is equal to 0, Q bar 1 for S is equal to 1. Whether R is 0 or 1, that's not a problem here. See, when it is connected to 2, it is actually bouncing back, but it will not go to 1. Okay. That is, it make a contact, then break a contact, again making a contact, then break a contact. Okay, like that it is going. So it is connected to 2, R is 0, S is 1, Q bar is 1, Q is 0. Okay, so after reaching the point 2 at position 2, it is bouncing. Okay, bouncing back, but it will not go to position 1, but it is bouncing. Anyhow, the switch is bouncing back and forth. Okay, so what will happen? This R value can change. Okay, see, when it is connected to 1, R is 1. When it is disconnected, the switch is disconnected, R is 0. Again it is connected, R is 0. When it is disconnected, R1. Again it is connected, R0. When it is connected, R is 0. When it is disconnected, R is 1. Okay, disconnected means this supply is connected to R, so it is 1, like that. So R value can be 1 or 0. But that bouncing won't affect the system behavior. Why? Because here Q bar is 1 and Q is 0 for S is equal to 1. Okay, for S is equal to 1, it is already defined. S is equal to 1, C S is equal to 1, Q is 0, Q bar is 1. Okay, now suppose if R1 came here, R1 came, so 1, Q is 0 only, no, this Q is already 0, 1 into 0, this Q is 0. Okay, this, suppose by chance this 1 came, it won't affect. Why? Because Q is 0, Q bar is 1. For S is equal to 1. S value is not changing now. Why? Because it is not going back to position 1. It is just bouncing at position 2. It won't go back to position 1. So that means switch never go to position 1. But it is bouncing at position 2. So the switches never go to position 1. So S value is always 1. So S value 1 means all the time whenever S value is 1, at that time Q is 0, Q bar is 1, and that is not changing irrespective of the value of R. Why? Because when S is 1, Q is 0, Q bar is 1, and that is fixed. Okay, then whatever may be the changes in R, suppose bouncing happens here. ഇവിടെ നിങ്ങൾക്ക് ബൗൺസിങ് ഉണ്ടെങ്കിൽ പൊസിഷൻ 2 ബൗൺസിങ് ഉണ്ടെന്ന് വിചാരിക്കുക. ബൗൺസിങ് ഉണ്ടെങ്കിൽ ആറിൻ്റെ വാല്യൂ 1 വരാം 0 വരാം. ബട്ട് സിസ്റ്റത്തിൻ്റെ ഔട്ട്പുട്ടിലെ റെസ്പോൺസിൽ വ്യത്യാസം ഉണ്ടാവില്ല. കാരണം എന്താ? കാരണം എസ് എന്ന് പറയുന്നത് ഓൾവേസ് 1 ആണ്. കാരണം ഈ സ്വിച്ച് നേരെ 1ലേക്ക് പോകുന്നില്ല. കാരണം 2 ബൗൺസ് ചെയ്യത്തേ ഉള്ളൂ, 1ലേക്ക് ഒരിക്കലും പോകുന്നില്ല. സോ അതുകൊണ്ട് ഇവിടെ എസ് 1 ആയിരിക്കും. എസ് is 1, so Q is 0, Q bar is 1, and it is not affected with irrespective of R value. This is about bouncing, switch bouncing.